Hello everyone. In today's video, I'm going to show you how to find a minimum value of a complicated logarithm expression. Here comes the question. P equals the logarithm of square root of a to base a over b minus 4 times the logarithm of a plus b over 4 to the base a, in which 0 is less than a less than b less than 1. Find the minimum value of p and state the value of a and b to achieve that minimum value. First of all, in this expression, the base contains unknown numbers a and b, which is unfavorable. Therefore, I'm going to change the base to the known number. It can be 2, 10, or e. It doesn't matter which one, as long as the known number. In this video, I'm going to use the natural number e as a base. After that, b equals log a over 2 times log a over b minus 4 times log a plus b over 4 over log a. I don't like the expression log a over b. Therefore, I'm going to do another substitution here by letting a over b equal to x. From the 0 less than a less than 1, b less than 1, we can get the interval of x, which is between 0 and 1. This interval will be used repeatedly in the future. This is the result after substitution. And log a plus a over 4x can be further written as log a plus log 1 plus 1 over 4x. In this expression, log 1 plus 1 over 4x can be further written as log x plus 1 over 4 minus log x. And the log a in the numerator can be cancelled with the log a in the denominator, leaves the whole number 4 here. Note that in this expression, log a is less than 0, log x is less than 0, and log x plus 1 over 4 minus log x is larger than 0. So, to make sure both the numerator and the denominator are positive numbers, we add some negative signs here. Note that minus log a appears as a denominator in the first expression and the numerator in the second expression. This reminds us the AMGM inequality. By applying this inequality, minus log a can be cancelled, leaving only the function of x in the expression. Note that in this inequality, the equal sign holds when the two fractions equal to each other, which we will use later. Now the question becomes to find out the maximum value of log x plus 1 over 4 over log x. To do so, let gx equal to log x plus 1 over 4 over log x, in which x belong to 0 and 1. A standard way of looking for the minimum value or maximum value of gx is to do the derivative test. However, in this question, the log function appears on both the denominator and the numerator. After the derivative test, it generates a transcendental equation whose solution is not obvious. So here, I'm going to do the guess and check to find the maximum value. If you are able to find a different method, please leave a comment. My guess is the maximum value achieves when x equal to 1 over 4, and the value is 1 over 2. The next step is to prove that for any x belong to 1 and 0 and 1, gx is no more than 1 over 2. This is the inequality we need to prove. Both sides of the inequality can be multiplied by 2 times log x. And note that log x less than 0. Then the inequality becomes 2 times log x plus 1 over 4, no less than 1 log x, which is equivalent to x plus 1 over 4 squared, no less than 1x, equivalent to x minus 1 over 4 squared, no less than 0. And this inequality holds true for any real numbers. This proves that what I guessed was correct. We plug 1 over 2 into this inequality and get p is no less than minus 2. And the equal sign holds when and only when two conditions. First, x equals 1 over 4. And second, the two fractions equal to each other. And we plug x equal to 1 over 4 into this equation. After a few steps of manipulation, we get the value of a, which equals 116. And the value of b can be further calculated, which equals 1 over 4. So, in summary, the minimum value of p equals minus 2, and it is achieved when and only when a equals 116 and b equals 1, 4. Problem gets resolved. Thank you.